friends, welcome to this session, Advanced Mathematics. I'm going to discuss coordinate geometry. In coordinate geometry, we have three topics, point, line and circle. First we will discussing the topic point, and we will make some revision which you have seen in 10th standard, that is distance formula. So friends, let us begin with that distance formula and few examples. As you all know that how to find the distance between 2 points, that is what we call it distance formula. It is something as under, suppose I take the axis, that is my x-axis, y origin. Let us take any two random points. Let me call it A, the other is B. The coordinates of B are x2, y2 say, that of A x1, y1. The distance between these 2 points, that is distance AB, as you are well aware of the formula that distance between A and B, which we denote it by, is given in this fashion: the difference of x coordinates, that is, let me say x2 minus x1 square plus y2 minus y1 square. x2 minus x1 square plus y2 minus y1 square. In other words, you may write even that AB square is nothing but square of the difference of x coordinates plus y2 minus y1 square. You have to just remember the formula and apply it in solving the examples. Let us find example how to apply this formula. Example number 1. Suppose we are asked to find the distance between the points between the points A cos theta, A sin theta, and B cos theta, B sin theta. We want to find the distance between these 2 points. Let us proceed. Let us call the points as x1 y1 and x2 y2 in order: a cos theta, a sin theta, a cos theta, a sin theta. The second point is x2 y2, which is b cos theta, b sin theta. We want to find the distance between these two. That is, we are going to apply this formula, that the distance between 2 points is given in this fashion. For simplification and simplicity, you may begin with AB square is equal to this. As we know that AB square is equal to difference of x coordinate, that is x2 minus x1 square plus y2 minus y1 square. Let us substitute the values of x1, x2, y1, y2. That is, AB square is equal to, we have x1, y1, x2, y2, that is something b cos theta minus b cos theta minus a cos theta whole square plus b sin theta minus a sin theta whole square. That is, the simplified part is given in this fashion: b cos theta minus a cos theta. So cos theta can be taken as a common factor, and that will come out as cos square theta. The remainder is b minus a whole square plus, similarly, sin square theta times b minus a whole square. Again, from the two terms, b minus a square is a common factor. We are left with cos square theta plus sin square theta. From the trigonometry, we know that cos square theta plus sin square theta is 1. So into 1 gave us b minus a whole square. So we are getting the square of the distance between a and b as b minus a square. Let us take positive square root both the sides, as this is distance between 2 points, so we prefer putting modulus sign, mod of b minus a. So the distance between given 2 points is this much. So this is the way of applying the distance formula given as distance between 2 points A and B. Okay, let us take one more note. As a result, the midpoint, madhya bindu, midpoint of the segment AB, line segment AB, where A has coordinates x1, y1 and the coordinates of B are x2, y2. The midpoint of AB is defined by the formula. Let us call midpoint as M. Then it is nothing but the average of the coordinates, that is x1 plus x2 by 2, comma y1 plus y2 by 2. That is, suppose this point is A, that is B, this is A, x1, y1, B, x2, y2. Then the coordinates of the midpoint M is given by this formula. Let us find the example based on the same. Let us call it example number 2, and we proceed as under. The three vertices of a quadrilateral એક ચતુષ્કોણની વાત છે જેના 3 શિરોબિંદુઓ આપણને આપવામાં આવે છે આ પ્રમાણે. The three vertices of a quadrilateral are 4 minus 4, it is minus 1, 3, and minus 5, 5. The requirement is find the coordinates of the fourth vertex. ચતુષ્કોણના 3 શિરોબિંદુઓના યામ આપણને આપ્યા છે અને આપણે એના ચોથા શિરોબિંદુના યામ જોઈએ છે. We want to find the coordinates of the fourth vertex. So let us make some drawing. Let us first write the coordinates of the vertices given to us. Let me call it A, B and C. Let us give some name to the coordinates. 4 minus 4, let me call it A. The other B, and third one, let us call it C, minus 5 and 5. So what are the possibilities for the same? Let us take it as under the quadrilateral which is given to us is parallelogram, अर्थात समांतर बाजू चतुष्कोणना 3 शिरोबिंदुओना याम આપણને આપ્યા છે અને ચોથા શિરોબિંદુના યામ આપણે શોધી રહ્યા છીએ. જે પ્રમાણે મને પોઈન્ટ્સ આપ્યા છે એના પરથી let us make a rough sketch and understand the problem. Suppose this is my point A. I am not taking the axis, so I can write the points the way in which I wish. Let me call this as B. There is one more, and let us call it somewhere C. So if we join it, the figure will look like something as under. As it is a case of parallelogram, from C, let us draw a line parallel to AB, and we complete the parallelogram. And from A, line parallel to BC, and suppose that fourth vertex, let us call it D. Suppose the fourth vertex is D, that is, these two are parallel, AB, AD and BC. And let us assume that let dxy be the fourth vertex which we are going to calculate. As we know, the diagonals of a parallelogram bisect each other. That is, midpoint of AC is equal to midpoint of BD. Midpoint of AC and midpoint of BD. That is, let us say, midpoint of diagonal AC equal midpoint of diagonal BD. First we will calculate the midpoint of AC. A has coordinates as under 4 minus 4, minus 5, 5. According to the formula of midpoint, it is nothing but the average. That is x1 plus x2 by 2, that is 4 minus 5 by 2 like this, comma y1 plus y2 by 2, y1 plus y2 by 2, equals the midpoint of BD. B has -1, 3. We have assumed the coordinates of D, x, y. So I have to take average of that, which is -1 plus x by 2, comma. The average of y coordinates, that is 3 plus y by 2. The midpoint remain same. There cannot be two representations of the coordinates of a same point. 4 minus 5, so it is -1 by 2. 5 minus 4 and -1 plus x by 2, comma, 3 plus y upon 2, like this. First value must equal to first one, that is -1 by 2 must equal to -1 plus x by 2, comma, 1 by 2 is equal to 3 plus y divided by 2. So now we have two equations from which we will calculate x and y as under. 2 to cut, let us simplify, and what we are getting is as under. So we are getting the value as under. -1 is equal to -1 plus x and 1 is equal to 3 plus y. So on simplification, it results in x equal to 0, y is equal to 1 minus 3, give us -2. So we say that, so the fourth vertex required is 0, -2. There were number of options. We were not asked find all possible fourth vertex. There can be more options for fourth one. As out of the options, we were required to find only one, that the fourth vertex required is 0, -2. Let us proceed ahead and find few more examples. This if A has coordinates -2 to B has 2k and distance between A and B, it is also written in this way: mod of AB bar, that is length of the line segment AB is given to us as 2 square root 5. The requirement is then find the value of K, then find the value of K. So let us recall our distance formula. It says that AB square is nothing but x2 minus x1, or you may write x1 minus x2 like this, plus y2 minus y1 square, where we are given the following values. The distance AB is given as 2 square root 5, where we are given that AB is nothing but 2 square root 5. That is our x1, x2 and y1, y2. Let us substitute the values. That is 2 root 5 in this way is equal to x2 minus x1, something minus 2 square, plus y2 minus y1. Let us take the difference of y, and we come up to here. Let us further simplify the same. 2 root 5 square is nothing but 4 into 5. We say it is 20, is equal to minus 2 minus 4 square is 16. We expand the later expression. 4 minus 4k plus k square. Okay. 16 plus 4 is 20, and 20 cut, and what I have is minus 4k plus k square is 0. If we take k as a common factor, we are left with k minus 4 equal to 0. The product of two numbers result in 0 mean either the first one is 0 or the second or the later. So that gives us two possible values as either k equal to 0 or k is equal to 4. So this is the way of applying distance formula and midpoint formula in solving the given sums. Let us have one more example based on this distance formula. We have something as under. Further, there is a triangle there is a triangle whose vertices are given to us. Prove that the points 2, 4, 2, 6 and 2 plus square root 3, 5 are vertices of an equilateral triangle, a triangle whose sides are equal, equilateral triangle. આપેલ ત્રણ બિંદુઓથી એક સમબાજુ ત્રિકોણ રચાય છે એમ આપણે સાબિત કરવાનું છે. Let us call the points as A, B, C, two plus square root 3, 5. We have to prove that the triangle is equilateral. So, we have to prove the following, that AB must equal to BC must equal to AC. So for that we have to use the distance formula. It says that AB square is nothing but x2 minus x1 square plus y2 minus y1 square. Let us first find the distance AB. So that is my x1 y1, x2 y2, and we start the calculation that AB square is equal to x2 minus x1, okay, 2 minus 2 square plus y2 minus y1, 4 minus 6 square, which is equal to 2 minus 2 is 0 square, the later, and AB square is found to be 4. We take positive square root both the sides. So AB is found to be 2. Similarly, let us proceed for BC square. So this will be treated as something x1 y1, x2 y2. I repeat, x2 minus x1. We proceed. So this is my x2 minus x1 square plus y2 minus y1, that is 5 minus 6 square. 2 and 2 cut. Square root 3 square is 3. The later 5 minus 6 minus 1 square is 1. Again 3 plus 1 is 4. So that was BC square. By taking positive square root, as it is dealing with distance, distance cannot be negative. So the distance between B and C, in other words, the length of the side BC of the triangle ABC is found to be 2. And finally, let us calculate AC square. A has coordinates. Let me repeat the same first. A has coordinates 2, 4. C has 2 plus root 3, 5. x2 minus x1 square. x2 minus x1 square is 2 plus root 3 minus 2 square plus y2 minus y1 square. 2 plus minus root 3 square. The later is 1. On taking positive square root, I find AC as 2. So on calculation, we found that each side comes out to be 2 units each in length. So I got the following result: AB equals BC equals AC. Each one is 2. So I say that I have proved it. Triangle ABC is equilateral. So in this way one can solve the given examples. Before we conclude, let us have just one more. Prove that. We are asked to prove some result. Prove that distance between the points which are given to us as under A cos beta, A cos beta, A sin beta, and the coordinates of the second point are A cos alpha, comma A sin alpha. The requirement is as under. Prove that the distance between these 2 points is twice A sine mod alpha minus beta by 2. So here we will be using distance formula as well as certain formula from trigonometry. Let us call our given points as A and B respectively. Then A is A cos beta, A sin beta. B is A cos alpha, A sin alpha. And we know that the distance between 2 points AB square will be given by x2 minus x1 square y2 minus y1 square. Let us substitute the values as it is given. A cos alpha minus A cos beta square, like this. A sin alpha minus A sin beta square. Cos alpha cos beta, A is a common factor. Okay, I will be left with cos alpha minus cos beta square, and the expansion of the same is cos square alpha minus 2 cos alpha cos beta plus cos square beta in this way. Similar simplification for the later term. It is like this: sin square alpha minus 2 sin alpha sin beta plus sin square beta. And let us rearrange the terms. A square is a common factor as a whole. I have got cos square alpha plus sin square alpha. Let me write cos square alpha plus sin square alpha. We are making a bit rearrangement. Cos square beta plus sin square beta. And why we are rearranging? As we all know that for any theta, cos square theta plus sin square theta is always 1. So we are left with 2 terms, from which if I take minus 2 outside, I have got cos alpha cos beta plus sin alpha sin beta. Okay, nice. So we are almost on the verge of the completion. As we know, a square is outside, cos square theta plus sin square theta is 1. From the formula of the trigonometry, cos alpha cos beta plus sin alpha sin beta is nothing but cos of alpha minus beta. This way, 1 plus 1 is 2. That is 2. So 2, we take it as a common factor. Then we are left with this one. Once again, we are applying trigonometry. Anything that is 1 minus cos theta is nothing but 2 sine square half of the angle, that is theta by 2. So, substituting that, I find that half of alpha minus beta mean I got 4a square sine square alpha minus beta by 2. So AB square is equal to this much. On taking positive square root, I find that 2 a square has a, sine square has sine, and I take modulus sine in order to confirm the positivity of the angle, as I know that sine of minus theta is minus sine theta and distance between 2 points can never be negative. So we have proved the required result. So we have proved the required result. So that was our discussion for part 1. There are different parts in this coordinate geometry. We will meet again in part 2. Thank you.